What I'm going to talk about is organics side, how the organics can be detected by our easy-to-use FTIR system or microscope or Raman system, which we don't have it here today. So instead of talking about it, I'm going to do a demonstration. So suppose I have a little material like this. I want to know what it's made up of. I can easily scan the infrared spectrum, then search the library. Here is a demonstration. So I start with measure sample, give it a name, and start the measurement. Now I'm going to put the sample over there and switch over, press it down. You will see a preview coming up shortly, and a nice looking preview. Now scan, get a high resolution, high quality spectrum in a couple of seconds. And it's going. And here is the spectrum of this material. The FTIR spectrum acts like a fingerprint of this chemical. It's very unique. Once you have the fingerprint, of course, you search infrared library and you will get a match. And see how good the match is? Every peak here match. And it says the material is polyurethane here. So we basically, in a couple of seconds, we identified what the material is this. Now, notice I have a big sample. I can easily do tiny sample, as tiny as 10 micron in size. Of course, we will need infrared microscope. So I'm going to switch over to the infrared microscope side. The first thing you do is you place the sample on the stage, which I do have a test sample over there. It's a dime over there with something on it. So let's scan the surface image first. So now infrared microscope is activated and it's scanning the surface image of this particular sample. You can see it's a very high speed. Every frame is stitched together to make a large infrared, a large visible picture of the sample. Notice the alignment, everything is fully, very precise and fully automated. So the operation of the system is extremely simple. It's just simply controlled by the joystick over here. There's no other control. Everything else on the system is fully automated. And the speed here, you can see, is very fast. So while it's scanning, we talk about this system a little. So this is the entire system here. It's very small, and it's the latest design. It's much easier to use. The entry-level person can operate the system in about 5 to 10 minutes. After 5 or 10 minute training, the person can operate the system and get a material identification for failure analysis, for QA, QC, or even for research and development work. Okay, so the sample image has been acquired. Now you noticed I have some special material over there. So you can really inspect individual material by just click it. It will go there directly. Okay, you can inspect individual items and go into individual spot to check where it is. Of course, this is the visible image. And I can easily switch over to infrared image, and it says I want to make a grid and measure a large grid. Like that, you can see the entire surface will be scanned and give you a high resolution infrared image of where is your chemical, what kind of chemical is it. So a couple of examples, what you can achieve by using this system. Here's an example. So if I have a polymer beads and there's a little brownish spot on one of them, what is that? It's a contamination. So we use the microscope. Notice the scale here is very small. It's only 180 micron, very small. And we can get the infrared spectrum from this in about 15 seconds. library search give you the correct ID of this sample as polyester very quickly. Another example before I finish. This is a liquid sample protein. Let it filter through a gold filter. You have lots of left over there. And what are they? Because these are in the protein sample. If you have contamination like that, it's potentially harmful to human. And we just filter them, get the spots and measure them individually. For example, the blue spot over here have a black stuff. It's identified as cellulose, so it's a contamination. You can do the red spot, which is identified as talc, and the green spot, which is identified as a protein plus talc. So very, very quick. Last example, we have a print circuit board, PCB board, and this device didn't pass the quality control because there's something wrong with it. It has been traced back to this little dark spot over there, and we want to know what that is. And the infrared microscope analysis show these red spots are the transparent protective coating, which is supposed to be there, and that's the red spectrum. And the blue one over here is on the contamination, and that's the blue spectrum. It looks different. So there's something going on. By doing library search, it has been identified the blue spot contamination is a human hair or skin fall into the process. So this kind of example shows the power of the infrared microscope. It can be easily deployed in a typical lab for failure analysis, quality control. And if you're interested, come back to the booth and we can sit down, talk about more detail, and even test your sample. Thank you very much.